All right, so today we'll be targeting on 5 questions. All right, we try to finish as many as possible. If we cannot, it's perfectly okay. All right, no stress about it. All right, as I say, I want you guys to try to really enjoy the lesson a little bit, and along the way, try to understand what is happening. All right, because practical mathematics is something which many of you don't like. Right, because the question is too long. It's like problem sums like that in primary school. None of you like problem sums, right? Yeah, you're like those simple 1 + 2, 3. Without question, right? Yeah. Okay. So anyway, I'll be going through as many questions as possible. If we cannot finish everything, it's perfectly okay. We try to finish as many as possible. Cool. Okay. So before everything, right, I want to just try to remind you guys a little bit about some of the formulas. All right. So there is something called like a circle. All right, and this is the center of the circle. So for example, right, all right, the question asks you to find the area of this portion. All right, this one is a little bit of the Sec 3 topic also, just to let you know. All right, so this portion, right, is actually what I call the area of a sector. So area of the sector, right, the formula is actually, you know this, right? You know this, but it's seldom being used. So area of the sector is actually theta over 360 times pi r square. What is pi r square? Pi r square is actually the area of the entire circle. Area of the entire circle. And what is this theta over 360 thing? This is like a fraction, a portion, right? A fraction, a portion of the circle, right? So the entire circle, right? The entire circle is 360 degrees, right? Right? The entire circle is 360 degrees, right? So one entire round is actually 360 degrees, but you're only taking a portion of it. And the portion is this portion, the purple portion. And this portion, we call it theta. All right, that is the name for the angle. All right, we call this theta. All right, why am I telling you this? Because later got question relating to this, obviously. All right, so that is called the area of sector, which is actually a Sec 3 topic. All right, but you should know this because you've done this in primary school. Sure, where got? God. Right, in primary school, remember, they draw you things like a circle. All right, and they say that this is like a 90 degrees down here, right? 90. Then they ask you to find the area of this portion. Yeah. Simply just take what? Just take pi r square, divide by 4 lah. Do you know it's the same thing? Do you know that pi r square divided by 4, right, is actually from what purpose? It's from where? Do you know that this is a 90 degrees? It's actually 90 degrees over 360 is a fraction of the entire circle, pi r square. Do you know that 90 over 360 is actually 1/4 times pi r square? Do you know that 1/4 times pi r square is the same thing as pi r square divided by 4? Oh, some of you begin to see the light. Oh, all right. So actually, you learned this in primary school already. All right, but in secondary school, we are a little bit more in depth. We teach a little bit more. We are more detailed lah. Can understand that, children? All right. So that is called the area of the sector. All right, a portion of the sector. All right. So if you need, right, if you need the area, you just times pi r square lah. All right, but if you need the circumference, right, a portion of it is the same thing. All right, so for example, if you need the red color portion down here, all right, you need the red color portion down here. This, in Sec 3, we call it the arc length. We call this the arc length. And the arc length, right, if you can, all right, it's the same formula. You take what? The angle, which is called theta, over the 360. All right, it's a portion of the entire circle. Times what? Times what? Times the circumference of the circle. All right, so the circumference of the circle is what? Circumference of the circle is given as 2 pi r. All right, so this 2 pi r represents the circumference. Can you see the beauty of the formula or not? Of course not. You all just don't like math, what? Can you see that? All right, so this is something which I think you it's actually not difficult, right? It's just something which you need to know. All right, and I'm just letting you know that this exists. Hey, you should know this. All right, and this is a little bit of the Sec 3 topic, the area of sector and the arc length. Right, it's supposed to be the term 3 topic. Okay. Okay, moving forward. All right, then we have the common things lah. All right, we have the common things in Sec 2. All right, you learn about the cone, right? You learn about the sphere. And you learn about the what? The pyramid, right? So all this must come into use. Hey, but sure, I learned this in Sec 2 already. Yes. You think in Sec 3 they don't ask? They will ask you, I tell you. All right. And just to let you know, when you're in Sec 3, right? When you're in Sec 3, Sec 1, Sec 2, Sec 3, things are all being tested. All right. You're not going to run away. All right. You're not going to run away from it. All right. So all these things will still be tested no matter what. Okay. So Sec 1, Sec 2, Sec 3 things will still be tested in your what? In your Sec 3. All right. So you cannot escape one. All right. You cannot escape one. It will always be there. Okay. So what is the volume of code and all this? All right. Hopefully you all still remember. All right. So we have things like the volume is equal to 1/3 pi r squared h. For the sphere is 4/3 pi r cubed. For the pyramid is the 1/3 times base area times height. All right, and the height is actually this height over here. All right, the one in purple. Oh, sorry, the one in blue. All right, from the vertex to the center is called the height. All right, so this is actually called the height. From the vertex coming down, perpendicular, this is called the height h. Okay, the radius will be this. All right, so all these they will surely come out again. Seriously, cannot escape one. All right, and we call it the total surface area. All right, so total surface area of the cone is what? Pi RL plus pi r squared. What is the L? L is actually the slant height down here. All right, so L actually represents the slant height. And slant height usually we need to use, remember, Pythagoras theorem. So all these topics are coming together already. Oh, okay, you're slowly able to see the linkage. So Pythagoras theorem says short squared plus short squared give you the longer square. All right, so C is like the longer side. Pythagoras theorem. Total surface area of the hemisphere is 4 pi r squared. And total surface area for the pyramid is the area of the sum of area of the sides. Sum of area of all sides. All right, so there isn't a standard formula for that. Okay, so all these formulas still must remember because they will still ask. Right, they will still ask. Okay, so this is just a recap because later we are going to do practical questions on measurations. All right, so all this just want you to have a highlight again. All right, so that you can oh yeah, done this before. Of course, you done this before lah. Okay, then in Sec 1 we learned something called a prism. Oh my goodness. So a prism is like a three-dimensional shape. A three-dimensional shape. With a constant area of cross-section. All right. So a prism can look something like that. This is like a triangular prism. Nice. Not bad, right? Okay, so this is a prism. All right, and this portion that is consistent, right, is actually called the cross-section. All right, so there is this formula to find the volume of prism. All right, it's actually area of cross-section times the depth or the height. So down here, right, I call this the depth because it's lying down. This is called the depth. All right, so area of cross section, the red color portion times the depth. And how do you find the total surface area? It's actually equal to the perimeter of cross section times height or depth plus 2 area of cross section. Okay, so these are some of the formulas that you need to know. Of course, there are others like the area of triangle and all this. I think this one you all should know, right? Right, area of triangle. All right. So it's like half times base times height. All this, right, supposed to know it, right? Half times base times height. Your teacher will assume that you know it. Okay, area of trapezium. What is a trapezium? Oh, yeah, I fall down. Trapezium got one pair of parallel lines. All right, so area of trapezium is half times sum of parallel line times the perpendicular height. Okay, so some of these are the very, very common one, which you need to know them, all right? They always comes out. All right, and the circle, I give it to you over here. The rectangle and squares, all these are easy. All right, so these are the things that you need to know for now. Okay, so if you are actually copying, good for you. All right, so you can actually have an idea, all right? Refresh your memory a little bit on these formulas. All right, so as you can see, all these topics, this particular topic, right, is all about formulas one. All right, so if your formulas, you can remember the formulas, right, actually it can score one. All right, it's very easy to score. All right, just to let you know for this portion. All right, you just got to remember the formula and put in the correct numbers. Okay, all right, so this is the first time you're going to see this worksheet. All right, there isn't any homework. All right, I tried to make the holiday program no homework so that at least you can celebrate your holiday a bit lah, huh? All right, if not quite sad, then you all have to what, do my work and all this. All right, I don't like. All right, I rather let you all have a good holiday, so there will not be any homework. So this lesson, right, just sit back and try to relax a little bit. Try to refresh your memory. All right, in regards to this type of question, this type of formula. All right, and yeah, and that will be good enough. Can? Okay. Okay, come. Let's take a look at the question. And don't worry, this PowerPoint will be uploaded into your portal. All right, you can actually click on live tutorial, click on the past lesson. You can actually download the worksheet or the PowerPoint slide. You can actually download this PowerPoint slide. All right. So when you download this PowerPoint slide, then you'll be able to see all this beautiful writing, drawing from me. Can? Beautiful, right? I know. So this is the sphere, this is the radius. Okay, come. Let's take a look at the questions together. Oh, building a railway tunnel. It's like an MRT like that. All right, so people are building the MRT and they are doing a very fabulous job, Imagine Singapore is an island, right? They drill hole here and there, right? Truly they are like amazing, seriously. All right, they can drill hole and they can make sure that Singapore will not collapse and all this. All right, I think it's quite amazing. Okay, so so all these railway tunnels, right, are actually running around Singapore, and not only Singapore. All right, there are many countries also have all these railway tunnel thing. Oh, all right. So anyway, Earth is being removed. All right, Earth means the soil is being excavated to make a railway tunnel because you need to dig out the hole. Right? All right, then inside the hole, right, you need to put in all this rail. All right, so that the train can move on the rail. All right, in order for the train to go from one end to the other end, all right, without having to stop for traffic and all this. All right, so it's a through train. Eventually, the train can reach a place faster, right, from destination to destination. All right, I think some of the countries like Japan and China, wow, they got all this bullet train, a very fast train, seriously. All right, very fast. All right, the maglev train using the magnetism, all right, to lift up the train in mid-air. All right, reducing the friction and all this. Wow, these are very powerful inventions. All right, yeah, bullet train, correct. All right, so all these inventions are really